Bismillahirrahmanirrahim. So find V naught t in the circuit of fig 1. Assume V0 at time 0 is equal to 5 volts. So we have an initial condition here which says that the initial voltage, this V0 at time 0, which is the voltage across the capacitor at time 0, is equal to 5 volts, and we have to find this voltage V naught t in this circuit. So let us transform this circuit to the frequency domain. So when we transform the circuit to the frequency domain, so we begin with this voltage source. So the Laplace transform of the 10 e raised power minus t u of t will be 10 over s plus 1, right? The Laplace transform of e raised power minus at is equal to 1 over s plus a. So the Laplace transform of 10 e raised power minus t u of t is equal to 10 over s plus 1. And this u of t just signifies that this function starts at time t0. Before time t0, this is 0. And then this 10 ohm resistance remains the same, this 10 ohm remains the same, and we have this capacitor with an initial condition. So we know that in the time domain I is equal to c dv by dt, and in the frequency domain this is equal to c using the time differentiation property of the Laplace transform. This is sv minus v0 negative. So that is I is equal to v over 1 over sc minus c v0 negative. So this is the impedance of this capacitor 1 over sc. So C, which is 0.1 farad, is 1 over sc. So C is 0.1, so that is 10 over s then. 1 over 0.1 multiplied by s, so that will be 10 over s. And furthermore, this capacitor will be represented with a current source in parallel with this capacitor, this current source, right? Or a voltage source in series with this capacitor. So because all these branches are in parallel, so we'll be better off using a current source in parallel with capacitor. So this will facilitate nodal analysis. So we'll use this source. So this CV 0 C multiplied by V at 0 negative is C is 0.1, and V at time 0 is 5. So that is 0.5 amperes. This source is 0.5 amperes, which is in parallel with the capacitor. Otherwise, we could use a voltage source in series with the capacitor. So this current source 2 del t, when transformed, this becomes 2 simply, because the Laplace transform of del t is 1. The Laplace transform of del t is 1. So 2 del t is simply 2 ampere source. So the transformed circuit becomes this is 10 ohm, this is 10 ohm, and this is 10 over s plus 1. This is 10 ohm, this is 10 ohm, right? And we have this capacitor here, right? This is 10 over s, 10 over s, which we have found out, and in parallel with capacitor, the initial condition is included in the circuit. Using this current source. So this current source is 0.5 ampere, 0.5 ampere, and then this current source is also transformed, and this is simply 2 ampere. And we need to find voltage V naught. So this is V naught across this capacitor, so we can represent a node V naught here, and we can take this as the reference node. So we can simply apply nodal analysis. So V naught minus 10 over s plus 1 divided by 10. plus V naught over 10 plus V naught over 10 over S minus 0.5 minus 2 is equal to 0, right? So we can multiply throughout with 10. So this is V naught minus 10 over S plus 1 plus V naught plus SV naught minus 5 and minus 10 multiplied by 2, 20 is equal to 0, right? So that becomes this is a constant term, this is the constant term. We take V naught terms separate, so this will be V naught into S plus 2, right? And that will be equal to, this is 25 and this minus turns positive here, this is 10 over S plus 1. So V naught is equal to let's V naught into S plus 2, V naught into S plus 2, V naught into S plus 2 is equal to 25 plus 10 over S plus 1. So that should be equal to S plus 1 here, and this is 25 into S plus 1 plus 10, and that is V naught into S plus 2, and that is equal to 25S plus 35 over S plus 1. So V naught is equal to 25S plus 35 divided by S plus 1 into S plus 2. So that is the expression in the frequency domain for the V naught, but we need to find out V naught in the time domain. So what we will do is now find out the inverse Laplace transform of this this expression, this equation. For this we use partial fractions to first expand this term so that which will facilitate us finding the inverse Laplace transform. So let V naught is equal to 25S plus 35 divided by S plus 1 into S plus 2 is equal to A over S plus 1 plus B over S plus 2, right? So multiplying throughout with S plus 1, so S plus 1 into V naught, so that will be equal to 25S plus 35 divided by S plus 2 is equal to A plus B into S plus 1 over S plus 2. So now if we put S plus 1 is equal to 0, right? So that is S is equal to 1. Let S plus 1 is equal to 0, that is S is equal to minus 1. So this will, when we put S is 1 is equal to 0, this term will disappear, right? And we will be able to find A then. So A is equal to S plus 1 V naught with S is equal to minus 1 substituted in this equation, right? So 25 minus 1, so that will be minus 25 plus 35 divided by minus 1 plus 2. So A is equal to 35 minus 25, 10, and that is 10 over 1, that is 10. So A is equal to 10. Likewise, we can find B by multiplying throughout with S plus 2 and then substituting S is equal to minus 2. So multiplying with s plus 2. So s plus 2 v naught is equal to 25s plus 35 divided by s plus 1 is equal to s plus 2 divided by s plus 1 a plus b, and we put let s plus 2 is equal to 0, which means we put s is equal to minus 2. So b is equal to then s plus 2 multiplied with by v naught with s substituted is equal to minus 2, and this is equal to minus 50 plus 35 divided by minus 2 plus 1, that is minus 1. So b is equal to this is 10 minus 5 and this is 15 divided by minus 1, so that is 15. b is equal to 15. So we have found out these coefficients. So we can now represent v naught of s is equal to a over s plus 1. A is 10 over s plus 1 and b is 15 over s plus 2. So now it is easier to find out the Laplace, inverse Laplace transform, because we know that the Laplace transform of e raised power minus at is equal to 1 over s plus a. Both these terms are in this form. So the Laplace transform and the v naught t is given by 10 e raised power, a is simply 1 here, e raised power minus t, and here a is 2, 15 e raised power minus 2t, right? And to signify that t is greater than or equal to 0, we multiply this by u of t. So this is the response of the circuit, the expression for v naught t in the time domain. So we have first transformed the circuit in the frequency domain, solved the circuit using algebraic manipulations instead of using an integral differential equations, and then when we found out the value of v naught in the frequency domain, we used inverse Laplace transform technique to find the response in the time domain.